Yeah.
Pens, pads.
I think this is my 5th year, is it? I think so. I don't know. Maybe
I feel like I saw them in the times before I was an organizer, because I joined at the same time as you as an organizer, Vic.
Yeah.
Yeah, back in the day.
That long time ago, yeah.
Why don't we do one of the first ones where it was just really user group things? So I remember going down to Norfolk, and we were in where Mark was organising one, and we were like in a little tea room, and there were like 3 speakers.
Vic, is your webcam working? You're not on webcam.
Ah.
There we
maybe.
are.
Maybe if I turned it on, that might help, maybe.
I'm not going to bother turning mine on because I'm going to be shooting off shortly as soon as everything is up and running.
There we go. We have a
I'll
Richard
leave
as well.
the rest of you to it.
Hi, guys.
Hi, Rich.
Hi there. Can you hear me okay?
Yeah, we can. Thanks.
Super.
Move that a bit further along, then it looks a bit more square rather than wonky.
Oh, that's because you just opened the spreadsheet I was opening, Alex. I was got confused about which screen was. Oh, no, it's not.
I did have it open a minute ago.
Yeah, it's all right. No, I've been on a training session all day, so my windows are all over the place to cope with someone else's layout.
That's a wholly inappropriate Mercian background.
What I'm sharing?
No, that I've got.
Still on from last night, I see.
Yeah, this is Warwick Castle. This is no good.
Oh, right. Well, I have my data relay t-shirt on.
I meant to take mine out.
Good point.
Completely forgot.
Get yourself a virtual background for a Kingdoms themed one.
I've got actually. I found a picture of the inside of Durham Cathedral, which is quite nice. I'm going to see if I can put that one on.
Picture of Gaza behind us.
Quite.
Yeah, I'm not sure you can do that whilst running just on the web.
Yeah, I don't think you can. I think it requires the app to do that bit.
Yeah.
All right. I think I've set everything up that I need to set up. So Victoria, Richard, Stuart, you good to run with this? You good if I log off now?
Yep. Good luck. We'll shout if we need you to turn anything back on.
Fantastic. Will do. I am now going to put my son to bed, so I'm probably going to ignore all your messages for the next hour or so. So you're on your own. Vic, since you're the host, I'm going to make you the full host now, which is going to downgrade me, and then I'm going to log out, and it's your ship. See you, folks.
Right.
Bye.
See you later. Bye.
Okay. Bye. So do we want to talk about orders of presenters? Who've we got on?
Well, no, Chris isn't here, but I think that's because the emails that got sent out, Kevin's on at 7:05.
Right. Okay.
And Chris is set for the 8 o'clock slot. So we'll stick with what we've agreed with people.
Yep, that's fine. So should we change the slide deck then?
Yeah, you want to just quickly edit that. It is just tonight and tomorrow night where people aren't in the order they're on the agenda.
Oh, right.
Because it's Kevin tonight and Tracy tonight, they just have to be the wrong way around on the webpage.
Oh, right, okay. But on the agenda, on the slide deck I'm sharing at the moment.
Yeah, on the slide deck, they're the wrong way around.
Shall I leave it? Is that fine? Yes.
Just change it so people don't get confused.
Right, okay. Oh, okay.
Tweet deck.
Yep.
Has Mr. Yates given us the YouTube location?
I think
no.
I saw.
It's in Slack, is it? I don't know.
Something just pop up in Slack.
I've got it. I'll tweet it out. Let's just grab that image as well.
Hello, everyone.
Hello, Chris.
Hello.
Hi.
Chris.
Yeah. It's coming up saying that I can't start my video because the host has stopped it.
Really?
I think, do you just need to promote to a co-host,
Um,
Victoria?
Yeah, you got the power for that, Vic.
promote to co-host. Make co-host.
Yep.
Yes.
There we go. Turn it off. Turn it back off.
Ah, there you go. So I can see you on the main screen.
Is that a good
So
thing
am
or a
I-
bad thing?
Yeah, I don't know. Am I still sharing my slides for people?
Yes,
Yep.
I am. Okay.
they're not in full screen mode. They're in.
They are. Yes, that's. I'm just editing it.
Oh, okay.
Hello, boy.
Yeah.
Good boy. You gonna be good tonight?
I'll try.
Yes, I
Right,
told us
so-
there, Stuart.
Now, okay. Oh, right, okay. I'll change that over. It presents onto the wrong slide. Life's funny, isn't it? Right, okay. Multiple screens, don't they cause lots of trouble sometimes? Oh no, it's done it the same. Why is that then? So what are you seeing now?
Your presenter screen.
Yes. So if I put it in presentation mode, that's the only. Perhaps I have to stop sharing entirely. Right. Okay. Let's see. Oh, but then I can't see that. Interesting. It's even more confusing at work. I have 3 screens. If I present first, I can't see the
Is that like a humble brag?
what?
Having it's terribly confusing having all of these screens.
Oh yeah, it is. So right, I'm not. Let's have another go. Share screen. So share screen 2 then.
Wow, that's more of me than I expected.
That is not.
It's all getting very Inception-like.
Does that look better?
Hang on, is that future me?
Yes.
Yes. Okay.
That's Tenant, not Inception.
Right. Okay. Oh, so I have to share the screen that's got the Right. Okay. As soon as I do that, I can't see Zoom at all. Completely removes any screen, any Zoom.
Yeah, that's PowerPoint for you. The way it blats all the screens is really, really annoying.
Yes.
Yeah, that's why I started using Keynote. It at least sticks to one screen and leaves the other one free.
Yeah. So did you want to try sharing your screen, Kevin? To see that.
Sure.
I haven't really used a Zoom before, so it's kind of.
Yep. All right. So by my sharing screen, it's going to stop you from sharing. But so we have done.
Oh yes, that's good. I can see your screen.
Yep.
That was more
and
efficient
there'll
than me
be
trying to share.
actually. Whoa! I've gone gone too far. And we'll have a bit of code. So
that looks good. And sound, I could hear you speaking, so does that sound all right for everyone else?
Yeah.
Cool. Chris, did you want to try sharing your screen as well, just to see whether that's...
Certainly can.
Yep, I can see that.
Bizarrely, it's thrown the rest of it all the way over the other side of my monitors there. So I'll drag that back here, and that's looking all right.
I like this. Everyone's more proficient at Zoom than I am.
And how's that showing up? Is that large enough?
I think it's big enough, but I'm
I
staring
can
at
see
it
it
on
big
the big
enough.
screen.
Yeah, I've got it on quite a big screen as well, so.
Happy with that, yeah.
Yeah, I suppose it's always best to try and make it as big as possible in case some people can't have little screens. Or I don't know whether lots of people have been joining via mobile devices or things. I don't know, but it'd be a bit difficult to see some of that.
I was going to say we can't cater for all.
No,
that's it. Yeah,
I only tend to use my mobile device if I know it's just going to be someone talking. So at least that way I can just put my earbuds in and walk around the house and get my chores.
Yeah.
And he's like, it's like a live podcast.
You can get that effect at any time by just closing your eyes.
Yeah, but then you might hear some snoring. It's quite a long day today.
Am I going first or Kevin?
It's Kevin.
Kevin.
Yeah. So hopefully your email should have said that, I think.
It probably did.
Yeah, that's fine. Right, so that's the tweet done.
So can I just ask why the 7 o'clock start as opposed to 6?
Just to try and give people a chance to get over dinners and things.
What about those that have dinner at 7?
Ah, well, yeah, that's it. It's who we annoy. Yeah.
That means it's dinner after 9 o'clock tonight.
Yeah. I may go and have mine now.
Yeah. Polish mine off before I joined. So.
So hopefully some people will start to join a little bit for a fun-packed evening of excitement.
So I'd say it's, I was supposed to be up in, I don't know if you guys have heard of a place called Anik.
Oh, yeah.
No.
Yeah.
Yeah, up sort of, well, it's about a 50-minute drive up for me. My under 10 football team are playing there tonight. Supposed to try and get up there for like a 6 o'clock kickoff, which is obviously never going to happen, but fortunately managed to get someone else to do that journey instead of me. So that's long way to go on a Wednesday night.
Yeah, because I've gone up for the day. There's a great bookshop there.
Oh, that's a beautiful place to go. I mean, to be honest, I don't often I go up there at least once, usually twice a year. But that's either with football or cricket.
Yeah.
I don't actually get to go and just have a wander around, or very rarely do we get to go and have a wander.
Yeah, no, my brother was living up in Edinburgh for a bit, so it was a handy place to stop off on the way up.
Mm-hmm.
Grinding up the M6 is not much fun. There's a bit more fun, but you want a break after you've been sat down a tractor for 20 minutes.
Yeah.
So Anik and Bamburgh are always a good place to stop.
So you're all still working at home, or have have you been into an office?
No, we've been pretty much thrown out of our building because the university wants to use the space for academics because it frees up all the teaching room.
Right,
All the academics have lost their offices to be, small seminar rooms or one-on-one rooms. So our place was set out, traditional IT looked like hot desk, but everyone was sat in the same desk all the time. So it was really easy to show up some plastic screens. And because we all left our screens and docking stations there, all the lecturers can just set up their laptop, plug in and go. And we normally spend a lot of money on building refurbishment and buying new ones each year. So if suddenly realize how much they're going to save if they can reuse the building we're in.
Oh, I see.
Yeah. I think we have 6 desks reserved for our department of 150 people.
Wow, that's not many desks, is it?
Well, I don't think they want us back on premise. The networking team are pretty much working on premise all the time because so many buildings are empty. It's a perfect time to rewire the network.
Yeah.
So,
yes, I can imagine that. Yeah.
The pictures coming out, the distribution racks are looking really nice and pretty now. Yeah. So finally managed to put all the cables out, restack the switches, and get them looking nice. Yeah, but that's about it. Everyone else is working from home. Very few people say they want to go back in.
Where's Mickey Robson tonight?
Mickey, I think he was on last night. We're only doing a couple of nights each rather than going for the full relay experience and doing 5 on the trot.
Yeah, he was on last night with me and Chris. Different Chris, obviously.
Unwin, was it?
Yes, it was.
So I think there were a few people that have joined, but I've shared my screen now, so I can't see.
Yes, sure. I'm just
I mean,
looking at the email. It does say that I'm supposed to be on at 7:05.
I'm sorry about that.
Yeah, I mean, it doesn't bother me.
Yeah, sorry.
I'll just bill you for the
I set up a mail merge.
Kubernetes clusters up. So
yeah, sorry. I tried to do a mail merge, and I believe it didn't work.
For both of those emails.
Sorry?
For both of those emails.
Yes. That's what I mean. I don't quite know how it works, but I got the Excel spreadsheet bit wrong.
So we're going with Kevin first then.
Yes.
We have 5 attendees already. Hello, attendees.
Hi, good evening. Anything in the chat? If you want to join in the conversation or tell us anything, the chat window is open. Just making sure everything works before Kevin kicks off at 7.
You perhaps let us know in the chat window if you've attended any data relay events in the past. That would be quite interesting. And any particular venues you've attended before would be quite interested to know.
Stuart will be very happy to field any questions about Northumbrian history.
Yes, that's a long way away from where I am.
Yeah. So no, unfortunately, recently I've just been reading about Prussian history and the Spanish Civil War. So
what in Northumbria?
That's no way to prepare for this session.
That's it.
Yes. No, that's funny. No.
And Kevin, of course, can fill us in on Durham's local geography.
Oh, absolutely. It definitely has dirt.
I see, yeah, because you're Durham in the US, aren't you?
Yes.
Yeah.
Hence the whole joke.
Yes.
Don't tell everyone.
And just don't ask for any directions, that you may not quite get to where you want to go to.
I've been past Durham on a train on the way up to last time data relay was able to happen.
Yeah.
Oh, yeah, because you joined us in Newcastle, didn't you? Yes.
Yes.
Is that the only one that you've done, or have you done some other ones?
That was the one data relay. And,
Yeah, he did the full week.
Yep. I was looking forward to 2020's data relay, and then 2020 happened.
Yes.
And some.
Yeah, it stopped everything in its tracks, didn't it?
Mm.
Oh.
We should wait and see how things go. The vaccine rollout is actually going better than I expected.
In the UK, but for a lot of like data events and things where you international speakers, you think it was going to be quite hard to get any of those things to happen until everyone's vaccinated.
Yeah, that's gonna be the tricky bit.
Yeah.
You know, it's just gonna be working out what the level of risk is. Which a lot is going to be mandated by the government and how they want to handle things.
So I wonder if events will go, you'll have like local events, but then everything will be broadcast as well. Hence our name, Data Relay Broadcast. That was cool.
That was a seamless segue.
Yeah, I recognise it. That puts it up there.
Oh yes, we've got a few minutes left before we get ready to start with a few introductory slides and then straight into our sessions.
Straight into our quiz about Northumbria.
Yes. So I think there's more than 5 old English kingdoms, isn't there?
Yeah, there's a lot more. We've not even picked them all from the same time period.
So Northumbria was one of the heptarchy, apparently, which, as the name suggests, of course, is 7. So that's immediately obvious to everybody.
Yes, you wouldn't have thought that, would you?
7 Anglo-Saxon kingdoms.
Yeah.
So we can keep going with data really till Sunday if you like and cover the whole lot.
I'm sure that we can find some really exciting sessions to fill the time for people. There is too many things to learn, too much content, and it just keeps changing all the time, doesn't it? So I think the data platform's far too big now to cover everything.
Pretty much. Well, it sort of covers. Yeah, it now covers almost everything. Now you can actually go and start talking about running stuff on Linux boxes, and if you're bringing things like Cosmos DB, or let's bring Hadoop back out the closet, and all the bits and pieces we've seen over the years.
Yeah, so it's quite difficult to be like an expert if you want to cover all of those off. I think perhaps some people are. I think it's quite a wide. It's gone far too wide to be really deep in every aspect now.
This is now where a role as someone such as a data architect really comes into play.
Yeah.
You need someone who understands your organization's data and works out, well, this data, it needs to be transactional, but does it need SQL Server, or can we go with Postgres or MySQL as a service? This data is going to get larger and larger and larger. Which one of the many big data platforms do we do? And, well, this data comes in at such a rate of knots. Well, we've got to look at IoT and streaming. So you need someone who's got an idea of all the technologies available to you across all the platforms. Yeah, because let's not forget, well, we're predominantly Azure people here. There's a lot of stuff out in AWS. Google's got some stuff at a really big scale. So yeah, you now need a data architect who understands all of that, not just how to set up a relational schema.
Yeah, that's it. And that's where we all came from. A lot of us came from, wasn't it? So it's bizarre, isn't it? It's just like, it's all great, but yeah, lots and lots of change over the last few years, isn't it? So
that's it. Well, change is good because if you embrace it, it's good job security.
Oh, it is. But there's loads of really exciting things as well. But yes, I found it's quite difficult sometimes to decide, well, which area do I want to like delve into in a little bit more detail, because you can't do everything at once. There's too much. Right, I think we've got 1 minute to go. That's according to the clock out that I can actually see in presentation mode. Oh yes, my phone says the same time. That's good. Right.
Perhaps you could help drum up the sense of anticipation, Vic, by singing the countdown theme tune.
What countdown theme tune?
You know, when they're answering the questions. Absolutely. Off you go.
I don't know that one. But it is 7 o'clock now, and I think we should start and just welcome to Data Relay. This is the third one of our set of events for this earlier Data Relay event in the year. Tonight we're Northumbria, one of the old English kingdoms in Britain. The agenda for this evening is 2 sessions, one coming up from Kevin and then one coming up for Chris, and there'll be a break in the middle so you can refresh yourself in between the 2 sessions. Let me just move the slide on, maybe. Oh, it won't move on. Oops, I've gone too many files. Right. So, yeah, so I'd like to just remind people that we do have a code of conduct, and that's just to be nice to everyone, and we'll all have a great conference. We do have a full version of our Data Relay code of conduct on the website if you want to have a look. If you've got any problems with anything, if you can send me a private chat on the Zoom chat, or to any of the other committee members on this evening, and we'll deal with that for you. And then there's plenty of time to sort of like network on the chat in between or a bit after as well. And you can think of things to say like, are you hiring any staff at the moment? Are you particularly looking for any roles? Can you connect to anyone particular that's on the chat that you want to, or on the session and things? And you've got any questions or anything about any of the sessions as well, you can enter your questions in the chat, and we'll be monitoring those, and then we'll feed those into the presenters, and hopefully they'll be able to answer those at a point during the presentation. These are our 2 speakers for this evening. Kevin's looking at does this look weird to you? An introduction to anomaly detection. And Chris later on will be talking to us about Kubernetify your containers. 2 exciting topics for this evening. And then that's the agenda again. Then at the end of the sessions, we would really like you to complete feedback. And if you do, we've got a drone that you could potentially win. So all the more reason to give your feedback to help make the events better, and to give the speakers some feedback, particularly on their sessions as well. And then we have a competition deadline, which is tomorrow at 10 a.m. for filling in that feedback. So what's coming next after this event? We've got East Anglia tomorrow, where we've got Tracy speaking about mental health and wellness in IT, and then Mark will be speaking on the edge of tomorrow, introduction to graph databases. And then on Friday, which is our final session of our relay around the English kingdoms, Demonia. We've got Annette Allen speaking about developing code to keep your DBA happy, and then Rob Sewells speaking on an introduction to Azure Arc enabled data sources. So feel free to sign up and join us for those sessions for the next 2 days in the week as well. Now, we hope you're going to enjoy the sessions this evening, and can hand over to Kevin to start us off for this evening.
All right, let's get sharing and get started. Good evening, everybody. Welcome to this talk on anomaly detection. So as mentioned, my name is Kevin Fiesel. I run a predictive analytics team here in Durham, North Carolina. I'm a Microsoft Data Platform MVP, and I have a blog called Curated SQL. The idea of Curated SQL is I try to find and link to 5 to 10 interesting posts per day on topics all across the data platform space. So it's curatedsql.com. What I want to do in this talk is go through a few things. The first thing that I want to do is really nail down what the concept of an anomaly is, and then we'll talk about some techniques for detecting anomalies. After that, I'm going to build an anomaly detector using ML.NET. And finally, we'll see how we can also perform anomaly detection via Azure Cognitive Services. That I'll consider a bonus section because I've got 45 minutes to get through this. So we'll see how I do. So first off, what is an anomaly? Second off, if you have questions at all throughout this, please do feel free to drop them in chat. I will have chat staring me right in the face, just like this. So my slides are over here. Chat, you're right here with me. What is an anomaly? Well, in short, we've got this concept of anomalies as outliers, something which is sufficiently different from the norm to merit interest. So both of those considerations have to be in play. It's got to be different from the norm because otherwise it wouldn't be anomalous, it would be normal. And it has to be interesting. Otherwise, it's just a point that's not that close to the mean or a point that's not very close to the others. So with that in mind, we have general conceptual explanations of anomalies, and then we also will talk about some technical definitions. Let's start on the general side. The basic concept of an anomaly is I'll know it when I see it. And you've already pointed out the anomaly in this picture. I don't even have to tell you where it is or what it is. You already see it. That is because as a human, you are actually really good at pattern matching. It's one of the things humans do pretty dang well. We've been working on this thing for quite some time, and the people who survive tend to be the ones who can match patterns best. So we get to take advantage of our ancestors getting eaten by lions until the ones who understood that, nope, that's a lion right there, I want to stay away, avoided the lion. So let's talk about the Gestalt school. The Gestalt school really formalized many of the high-level concepts of how we interpret things and understanding the brain as a pattern matching system. So their key insight is the brain works by taking signals, visual signals, and then applying known concepts, expected patterns to those visual signals, and leads to some interesting findings. One of the key things is that we're also really good at ignoring things that we can't quickly explain. So one of my favorite examples is a YouTube video where it's basically people passing around a basketball, and your job is to count how many passes there are. And as they're passing this basketball, a person in a monkey suit walks onto the screen, kind of does a little dance, and then walks off the screen. And a fairly large percentage of people get so focused on counting the basketball passes that they don't even see the man in the monkey suit walking on screen. That's what our brain does for us. So let's talk about some of the good sides of these mental patterns. we have this law of closure, which says that we will naturally fill in gaps and turn partial shapes into whole shapes. So I don't have any true shapes on here. I have dots and lines, but you're able to make that into a square, circle, and a triangle respectively, because your brain's capable of filling in the gaps. The law of common region indicates that if I put something in a box, we will naturally assume that things inside the box and things outside the box are different, because otherwise everything would be in the box, right? So we see two groups here, even though they're exactly the same blue dots. I copied and pasted them myself. Here we have an interesting picture of how the brain likes to see foreground rather than background. And if you're in chat, if you want to participate in this, tell me what you see in the two images. And more specifically, tell me the first thing that you see. Because it turns out that based on coloration, based on, say, my background versus setting other backgrounds, you may see different things in these two images. So Victoria says on the right side, black faces. Jeffrey says white faces on the left side, the white vase on the right side, both on the black background. Yeah, so you will actually see different people will get one versus the other. Chris says faces on both. So some people will pick out one aspect, some people will pick out the other. Quite often in a painting like this, it could actually go both ways, and it kind of depends on what the background looks like, where if I have a very light background here, you might pick up the vase on the left side faster and the faces on the right side faster. But it is interesting to see which thing people see first. And this is called Rubin's vase. The law of proximity is an indicator that things that are close to each other we consider as part of a single group. So the three dots on the left we consider as part of a different group than the one dot on the right. So this leads to this concept of normal versus abnormal separation. Things that are fairly close to one another considered part of the same. They're part of a group. Similarity, meanwhile, indicates that there are certain aspects which will group things together based on, say, color, shape, or size. In this case, I kept the shape and the size all fixed, but I changed colors for some of the different dots. And we will naturally associate all of the blue dots together. We'll associate all the gray dots together, all the yellow dots together, because the mental implication is the fact that they all look similar indicates that they are probably similar. And the fact that there is a difference, that I used coloration to separate out these things, is an indication that we should separate them mentally. Continuity is another fun one. Here, I want to draw real fast, and we want to follow the smoothest path when viewing lines. Ideally, if this were black and white, you would probably want two lines, one line like this, one line like this. However, because I added in color, we have to adjust, and the brain doesn't like this. It doesn't like this sharp curve and this curve down. It would much rather have a straight line and a smooth curve. So this is in contrast to what the brain kind of wants to do. And you may, as you're looking at it, it may feel a little weird for that reason. Finally, symmetry and order. We, as pattern matchers, like to take complex things and attempt to break it down into smaller components. So on the left-hand side, that is a complex shape. But your brain has probably already picked out, well, it kind of looks like a triangle, a circle, and a square, which is what it looks like on the right-hand side with the three different colors. So that is your brain attempting to disassociate portions. And this is great because now I can see that lion even if it is hiding in some grass. So it's not 100% lion, it's lion plus grass, but hey, that thing looks like it's about to eat me. So let's get away from there. How does this apply? Well, aside from being fun to learn about, this does apply to anomalies. because humans are pattern matchers. So we will look at observation points and attempt to make patterns. We'll attempt to see things. We will try to use fairly simple heuristics to identify what may or may not be normal. So here I have a week of American football passing yards versus points scored. And mentally, you're probably looking at this and saying, there's a line somewhere around here, and we have these 2 points that appear to be weird. They are different. They don't really fit close to that line. So we're able to take advantage of this pattern matching that says, yeah, that looks like it's going in a common direction, and then impute that line and then see, yep, those two points at the bottom look a little strange. So I would consider that a fairly cogent observation based on the fact that I'm just showing you some dots on a screen. Now, of course, people can also take advantage of this. A lot of optical illusions take advantage of the things that you found in the Gestalt slides. So in many cases, we attempt to show you something that's impossible, but your brain has difficulty discerning it. So most optical illusions generally will be based on one of those rules. As mentioned, our eyes try to fit a line. Now, this dotted line is the best fit line, which includes those 2 points at the bottom. And they do make us wonder about those 2 points that are dragging everything down. So, all right, that's a high-level conceptual explanation of outliers. But I want to dig in and explain it from a more technical side, because I'll know it when I see it is okay, but it's not perfect. Our brains are pretty good pattern matchers, as I mentioned, but they're not perfect, and they will get things systematically wrong in certain cases. And this is where we try to put together a stronger technical analysis to help find things that the brain doesn't pick out very well. So, first definition of the technical side for an anomaly. We have here a normal distribution, approximately a normal distribution. So I generated this normal distribution, and this is normal because it has a mean of 0. Let's call this roughly 0 right here, because I'm not very good at drawing, and a standard deviation of 1. Now, what that standard deviation tells us is roughly 68% of the data points will fit in this range. 2 times the standard deviation will give us about 95%. 3 times the standard deviation will give us about 99.7% of data points if this is a true normal distribution. We have over here a few data points, and I manually edited those. They're out in that 7 or 8 standard deviation range. To give you an idea, the likelihood of that, you can probably measure. I need to do the calculations, but consider it in the trillions or quadrillions. So 1 in a quadrillion chance of a point showing up that far out, or at least 1 in a trillion. So the fact that we have several points out there is an indication that, yep, something is weird about this if we assume that the distribution is a normal distribution. That's very weird. It's beyond the likelihood that we set for probability that a point should be in here. So as I mentioned, 99.7% are within 3 standard deviations. Now, of course, that means you will have 0.3% that are outside of that range. And if you throw enough data points in, you will eventually find something that far out, but it may take a while. Next, box plots. I love box plots. They give you a lot of information tied up in a very small amount of space. So let's cut through this box plot. We want to start by talking about the median. The median is the 50th percentile. This is the midpoint in a data set. Now, in this particular case, this is the number of invoices by year. So each box represents 1 year, and each data point represents a month. So we have 12 data points per year. The 75th and 25th percentiles represent the size of the box. So this is also known as the interquartile range. This represents 1/2 of the data points. You can see this guy's got a bit of spread. Then we take this interquartile range, we multiply it 1.5 times that interquartile range. So, that might be like way up here. And then we find where is the highest data point that is below that line. Or we come down here and we say, okay, well, where is the lowest data point that is above that line? And those represent the whiskers. Finally, if you have a point which is outside of 1.5 times the interquartile range, that is an outlier. So another technical definition of outlier. The first one that we had was you are so many standard deviations away from our mean. This one is you are so many times beyond the interquartile range of the median. All right. Third example, process control chart. So a process control chart is something that gives us an understanding of if a process is in working order or if it has gone out of working order, or in other words, if it's in control or out of control. Just to give you a visual indicator here, in case you have trouble seeing the gray, this gray is supposed to represent the normal range, the acceptable range. So imagine that you're working with a router, the metal working kind, not the type that sends packets, and you must mill a certain metal within a certain tolerance. So we're shaving off metal, and it has to be a well of a certain depth and certain width, and we have a given tolerance. And we're building these things out because we're machine working, and we're going to take these components and put them together and do cool things with them. If your cut is beyond the allowable width, beyond the tolerance, then we can track that and we can say, uh-oh, there's a problem. A trained specialist may be able to look at this chart and say, oh, our width has suddenly gotten much wider than we expected it, and it's actually getting worse. This means that I need to perform this operation on the machinery to tighten things up. And then everything can go back to normal. Perhaps it's I need to add more oil to the metal, or I need to tighten some screw. Maybe some vibration has jarred it loose. So regardless of the actual cause, which I can't give you based on this picture, a trained technician may be able to look at this and indicate, yep, here is what is the issue. And based on my experience, I can see that this is not normal, and therefore I can act on it. So third definition, technical definition of an anomaly, when we are out of control from a given process, when we have left the acceptable tolerances of a given process. So we have those definitions, both technical and I would say non-technical. Now I want to talk a little bit about the types of data that work best for anomaly detection. So when you're looking for anomalies, we want data sets with certain properties. Ideally, you've got one numeric feature to measure and at least 30 data points, preferably at least 60 or 90. Essentially, the more data points you have, the more likely you are to end up with a decent model. Minimum, you probably want at least 15 data points. As you get below that, it becomes really tricky to tell if something is actually anomalous or if you just haven't seen things that should be there yet. So what I mean by that is if I can pull from a pool of a certain size and I've only pulled from one corner of that pool and I pull something from, say, the middle of it, that may look weird because I only have a few data points and they're all clustered in one section. But as I pull more and more and more, I'm going to get different pieces from around the pool, and it'll form up into a more appropriate shape that closer fits the population. And my end result is I'll see, oh, no, that actually wasn't anomalous. It's just I didn't see enough data yet. We also want to see at least one cycle of behavior. So think of seasonality. For example, if I'm selling beach umbrellas sell really well in the summer. They don't sell very well in the winter. As a result, I need to have ideally at least 1 year's worth of data about beach umbrella sales to pick up that sort of seasonality. If I only have the months of January, February, and March, I'll say, okay, well, beach umbrellas don't sell very much. And then April comes around, things start warming up, at least in some parts of the world. And people buy those beach umbrellas and we're like, oh, this is really weird. Something strange has happened. Yes, it's called summer, or at least spring. It happens most years. So having that cycle really helps us out. And having more than one cycle lets us figure out the difference between what is seasonal, just beach umbrellas sell better in the summer, versus what is a trend. Beach umbrella sales have been going up because celebrities have been endorsing our beach umbrellas. They're the best umbrellas ever, they say, and that drives people to buy them. So we have different causes that may explain why we have changes. And the more data points we have and the longer the period we have, the better we can explain why something has changed and understand if it truly is anomalous or if there is an underlying cause that is explainable, understandable, and that we don't necessarily have to act on. It's not interesting to us in that regard. So do we need time series data? Well, Betteridge's law of headlines says no. In case you've never heard of Betteridge's law of headlines, this is one of my favorite laws. This states that if a newspaper headline starts with a question, the answer is usually no. So time series data, and try that out, by the way, next time you see a newspaper, if you ever see one of those. Time series data is used extremely frequently for anomaly tracking because usually we care about anomalies in a temporal fashion. We care about them over time. So that process control, has the thing just recently gone out of control? Now we have to act on it. Did it happen a while ago? It looks good now. But suppose that you are interested in looking at data within a given time frame. You can still do anomaly detection. I mean, I gave you an example earlier. In this case, this was 1 week of American football where I tracked passing yards versus points scored, and I can envision a way to detect anomalies. You know, we talked about, yeah, I can kind of see those 2 points that look weird. But in this case, the assumption is that all of the members have the same operation function. And what I mean by that is we assume that they all follow by approximately the same rules. So if I have, for example, here we've got NFL rules in 2019 or 2020. And if I also add in teams from the 90s and teams from the 1970s, the rules were radically different. And as a result, the yards versus points scored would be quite a bit different. So we wouldn't necessarily expect the relationship to be the same over that far of a time gap because of how drastically the game has changed. As a result, they wouldn't have the same operation function. So let's talk briefly about some techniques, and then we'll get into building an anomaly detector in .NET. Quick intuition. There are a lot of anomaly detection techniques out there. You can hit the papers and find everybody's got their own approach. But boiling down the commonalities in many of those approaches, points that are clustered near each other are less likely to be anomalous. That goes back to the law of proximity from the Gestalt school. Usually, there are relatively few outliers, because if it was the most common point, it wouldn't be an outlier, it would be normal. So as a result, we can isolate those outliers. We can spend a lot of time focusing on those outliers and could even use some computationally expensive techniques on those because it's a relatively small part of a very large data set. With time series data, our intuition is changes should not be drastic. You think about a person, say, running speed. I want to calculate how quickly you accelerate, how quickly you get to top speed, and how fast that top speed is. If I'm tracking that, you don't generally go from 0 to top speed in the first step, nor do you go from top speed to like 0 and then back to half speed over the course of 3 steps. There's a curve, and with most time series data, we tend to see curves. We don't tend to see major discontinuous jumps. And if we do see a discontinuity, that is usually an indicator that there's something interesting here. So I mentioned standard deviation. A brief point on standard deviation is that the larger the standard deviation is, the more points would be valid. So within this curve, this blue curve right here, standard deviation is 5. So if I say 3 standard deviations from the mean of 50, that would put me in about 35 to 65. So for a score above 65 or below 35, we might consider weird. If your standard deviation is 20, 50 plus 60 actually puts us above the top score of 100. So any score in this green curve is normal or reasonable. But if I got 100 on the blue curve, that would be weird. Now, the downside to standard deviation as a calculation is that it is very sensitive to outliers. So if I plug these values into SQL Server, I've made it a SQL Server talk now. So if I plug these values in, the standard deviation will be 0.85, and the mean will be 8.65. Now let's say we have one outlier, real outlier, 1.9. I mean, when you see that these values range from 7 to 9, this one's definitely off. But simply adding this one data point in more than trebles the standard deviation, and it drops the mean by a full point. So what this does is that with my initial calculation, 8.65 and a standard deviation of 0.85, if I said I have a value 5.1, is that weird? Is that anomalous? And we use the definition 3 standard deviations from the mean. Then 3 standard deviations from this is 6.1. We look at that number and say, yep, that's different. That's an outlier. However, 3 standard deviations of 2.67 from 769, no, that's no longer an outlier. So it's good that we learn from information. You know, it's, as a Bayesian, I like that. But I think we're kind of jumping too far. We're pushing this too far too fast. One outlier should not completely wreck the curve. And that's where we get to the concept of robust statistics, where a robust statistic can handle some limited number of outliers before it breaks down. MAD is an example of a robust statistic. So this is the calculation is basically you take your value, subtract it from the median, absolute values of those, and you take the median of those differences. So here are our numbers once again, and the median of those numbers is 8.75. Well, how did I get that? Calculating median is pretty easy. You start out with prison rules. With prison rules, you find the biggest, meanest, nastiest guy in prison and you shank him first. Now that you're in charge, you can take care of the little guy. And we just keep knocking off smallest and biggest until we've got either 1 or 2 data points left. We have 2 data points left, so we're going to take the midpoint of those 2, which is 875. So 9.1 minus 8.75 is 0.35. We take all those calculations, absolute values of all of them, so they're all positive, and we get the median of those. Well, again, same rules. You knock off 0.35 and there, and you end up with 0.55. Now we add in an oddity. We add in that 1.9. Well, that actually doesn't change the median very much, because once we knock out the first one, we knock out the oddity next. So outliers tend to get thrown away first from this. And if your outliers go in both directions, like you would expect from a statistical distribution, they cancel each other out, which is great for us because it means that the median doesn't change very much. It changes, but not a huge amount. And the MAD changes, but not a huge amount. So we learn from the outlier, but it doesn't throw us out of whack. Next up, differences. I have a trend with an anomalous jump. So I've got this trend. This blue line is obviously going upward over time, but I also obviously have this strange jump. So how do I separate the trend from the anomaly increase? And the way that we do that is a couple steps. First, we figure out what the data point looks like. We detrend it is what it's called. We fit it with a line and then subtract the value of that line. So now we can track the differences, the vertical difference from this dot to this line, and that gives us a calculation of how far off we are. So this is, again, going back to seasonality and trending, this is how we deal with the idea that celebrities endorsed our product, everybody wants to go buy it now. It's not anomalous, it's just that's part of the trend. But for discontinuities, we have change point detection. So this is a case where you would expect to see time series movements tend to be fairly smooth. If I have a major jump, that is an indication of some underlying fact has changed, or maybe I have bad data, or something has happened. And regardless, those are interesting to us because I want to understand why did we have this big jump or that big drop? And that's what change point detection looks for. Finally, differences. So we can do all of these different calculations with the actual values, or if you're doing time series analysis, you take the current point and the next point, and you subtract the difference between these two, and you perform the same calculations across those differences. So I have thrown a lot at you over the course of the last half hour. If you have questions, please feel free to drop them in chat. Otherwise, we're going to take those scholarly findings and plug them into some programs and get some interesting results. Now, you can go build your own package. You can build your own process to perform anomaly detection. My team actually did build a package to do this because we had specific requirements we had to follow. But if you're starting out from scratch, I highly recommend checking out some of the pre-written packages. If you're in R, Anomalies is fantastic. If you're in Python, Anomaly Detection Toolkit and PyOD are really good. If you're using C# or F#, ML.NET is acceptable. If you have access to a REST API, Azure Cognitive Services has its own Anomaly Detector API, which is really good. But let's say you are absolutely certain you need to roll your own. If you're in the .NET world, I highly recommend this package, MathNet. So MathNet is a series of libraries. It's a series of NuGet packages, which allow for numerical and statistical analysis in C# and F#. Many of the tests that I talked about are things that you can do in a few lines of code in MathNet. And I have some examples of the types of tests that my team has built. I am not actually allowed to show you the code, unfortunately, but to give you some inspiration, you can get standard deviations from the mean or median absolute deviations, deviations from interquartile ranges. You can get difference calculations or actual values. And all of this stuff is relatively few lines of code. So if you do want to go that route, MathNet is going to be your friend in the .NET world. But let's say you don't want to do that. Maybe you're happy to have learned about the techniques, but then you say, but I'd really like something that's just put together that I can send it some numbers and determine was there an anomaly. And this is where ML.NET comes into play. This is an actively developed library, and despite the low-key shade I just threw at it, it is a reasonable library. So it's under active development. Most of my distaste toward it is that they're definitely heavy on the C# side and not the F# side. But if you are doing machine learning in .NET, this is probably the best library available to you. So let's say we want to set this up. We want to try it out. If you're in Visual Studio Code or maybe on a command line, just a few lines of code to get started. .NET new console, create a new console app. My language will be F# because that's how I roll. I'm going to add Microsoft.ml as well as their time series data set. And I'll also add xplot.plotly because I want to visualize results. So let's go into Visual Studio Code and check that out. I need to close that one. I need to open up the basic anomaly detection program. All right, my data set that I'm going to look at is stock data for GameStop. Now, I want to figure out just how diamond-handed people are. And this is a stock which I think anybody can agree has had some weirdness associated with it over the past few months. I have enjoyed the weirdness immensely. Give you an idea of the data set. We have just a few columns. Basically, the date, the open value in dollars, the high and low in dollars, the closing and adjusted closing value in dollars, so share prices, and then the number of shares sold over the course of that day. We are going to focus on closing price per day, just to make it easy. Here is our program. I'll bump in one more. This was adapted off of another blog post. I made some significant changes to the visualization, but a lot of the code looks pretty similar. So I wanted to give credit where credit is due. Using Microsoft ML and xplot.plotly, we are going to work on this price data. So price data is in C# terms a class, in F# terms a type. And it has all of those values that we talked about. So open, high, close, adjusted close, volume. We also have a data path. Where is my data file located? So my CSV file that has data. I'll create an ML context and load my price data from the data path into that record type. And that'll be in data view. So that's where all of my data is. It's a fairly easy way to load data from a CSV, which is surprisingly difficult to do in .NET compared to R or Python. So that's part of why the ML.NET team took this approach. I have two pipelines, one for anomalies, one for change point. So for anomalies, we detect a spike, and for change point, we detect change points. We're going to use the closing cost, the closing price of the day. And for anomalies, we'll look both sides. It can be an anomaly high or low. For change point, our martingale type will be a power distribution. I'm not getting into that. We will accept it as is for the course of today's talk, and we can talk about that some other day if you'd like. We'll fit the model. So we take our data, we're going to train a model fitting our trained data to it. We'll transform this into a view that we're able to work with and create a list of essentially price prediction results for anomalies and change points. So that gives us back a list of all the anomalies, a list of all the change points. And from line 98 down, this is just code to visualize using Plotly. So instead of talking through this so much, how about I say, go in here and run this code. And then what that's going to do is give us a chart. That looks like a pretty cool chart. So this is the stock price of GameStop, where it started out last year in the $4 range. And you can actually see some anomalies down here that were, hey, this jumped up by $1, and that was anomalous because it wasn't generally moving that much. And then January happened, and the share price went from the teens up into the 40s, and it just took off. At its peak, its highest value was just under about $400. But then that next day, for various reasons, it dropped to under $200. And then the day after that, for other various reasons, it jumped back up to $300. And then it collapsed back down into the 40s. Then it took off again. And then it's been bouncing around at about $160 per share for the last few weeks. So, a couple of points of interest here. We have a lot of anomalies. I'm going to hide the change points. We have a lot of anomalies early on. But then once the real crazy started happening, and we have this cluster where basically every day was an anomaly, after that point, none of these are anomalous because basically the algorithm has learned that any value from, say, 30 up to 300 is apparently acceptable because it's happening, and it just keeps happening. So the variance has jumped up so much that even if we go from $137 to $260 over the course of a couple of days, apparently that's normal now. So .NET Machine Learning's, ML.NET's anomaly detection system will pick up on that behavior over time. And this is actually looking at the whole data set. There is another approach where you can look at it as windows. So I can look at just the prior 10 days and the current day. So is the current day weird based off of what the prior 10 days look like? And in that case, if we saw a spike to 260 right here, that would be considered weird. But over the course of the entire data set, it's no longer weird because apparently this stuff happens now. So that's a quick feeling for what anomaly detection looks like in .NET. The actual code, you saw it was roughly 90 lines. And that 90 lines included quite a bit of code for the class. And the actual anomaly detection was, what would I call that? 30 lines of code, because we kind of start right about here at 45 and we get up here to 97, so maybe 50 lines of code. So not that bad for I'm getting anomaly detection in my .NET application. That said, you can also use the Azure Cognitive Services anomaly detector. And I won't go through the demo for it. I do have a demo. Consider that extra credit if you wish. The Anomaly Detector API in Azure Cognitive Services allows you to perform the same sort of anomaly detection from any language that supports hitting a REST API. So .NET, Python, Java, pretty much any language you can think of can hit REST APIs. You create a resource in Azure, save your key and endpoint, and then create an app and work with the API. So it's just a few steps of a process. In the Cognitive Services Marketplace, it is called Anomaly Detector. So that's the thing that we'll be looking for. And when you create it for your subscription, there is a free pricing tier. This gives you 10 calls per second, 20,000 calls per month. Obviously, if you're running a large data set in production, that's not enough for you. But for playing around, it's definitely more than enough. So you don't have to go on a paid plan for anomaly detection in cognitive services, not until you start talking about production workloads. In the keys and endpoints, you can grab the key and the location and save those someplace. In case you didn't know, set X sets an environment variable from the command prompt. So set X anomaly detector key, and my key will write that as a system level environment variable if you have access to do that. And what is cool is that there is a demo app for the Anomaly Detector API. So let's do that real fast, and then we're going to call it a day. I do need to get my API key. So that will take me just a moment as I log into Azure on this other screen. Okay. Got this key. Unfortunately, I need to show you my key. But that's all right. So there are a couple of examples. Here's the last API. This is what I was talking about, where it looks over the course of a window. And we can see different values being put in or not based on whether they're considered anomalous. And as we're going through this data set, it's already pointed out that, yep, it looks like we have several anomalies here. So we could sit here and watch this thing play out over the course of the entire data set, but that would take a while. So I'm going to stop that. Just remember, we've got 5 data points in this range. If I look at the whole sample and run this, you'll notice that there are fewer anomalies. So over the course of the whole batch, those minor changes actually weren't considered anomalous. Over the course of a small window, they are anomalous. This is a factor that your window does matter in whether something is weird or not. And speaking of weird, I have now regenerated my key. So if you were hoping to take that key and, I don't know, detect some anomalies for free, sadly, no longer able. So I've also closed the window that contained my presentation. So let's pull that out and let's wrap up this talk, because we are right at the end, which is good because we're also right at the time. Jump all the way over here to the end. And there's cognitive services set up. There's a whole demo on that. But over the course of the talk, we have given a pretty good concept of what is an anomaly, shown some techniques for detecting them, and also a couple of .NET packages to make it easy. One of them is ML.NET, which we talked through. The other is Azure Cognitive Services Anomaly Detector API, which is something that if you grab the code, you'll be able to check out yourself. If you'd like to grab that code, go to csmore.info/on/anomalies. And if you have any questions afterwards, please do feel free to follow up with me, my email address, my Twitter handle. And with that, if there are any questions, I'm happy to take them. Otherwise, time for a break. So thank you, everybody.
Thanks very much, Kevin. Brilliant session. If there are any questions, please put them in the chat, and I'm sure Kevin will be able to answer them now for you.
I wondered if I could jump in with a question, actually, Vic. I'm going to take advantage of the fact that I've got audio privileges.
Right, yes, go away.
That was really interesting, Kevin. Thanks so much. I'm just a lot of that was, I mean, you alluded to the sort of very scholarly introduction, and I wondered about use cases for this, or places where you've actually sort of deployed this, some real sort of world examples where you've been able to employ this sort of anomaly detection profitably.
Yeah. So my day job, I work for a company that does assists companies in selling on online marketplaces. So we have anomaly detection for things like demand forecasting. We have predictions of how many beach umbrellas are you going to sell in April, and is that value unexpected based off of what you normally would see. So that's one case. Another case is if you're thinking about it from the standpoint of a DBA, we get database errors. We have database errors, and there's some natural level of noise. We could look for uncommon levels of noise. So this is more than I normally see, more errors than I normally see. Some of it is just, all right, people are gonna make mistakes. People are gonna type in the wrong keyword and get the syntax wrong, or there may be an issue. You may see the occasional deadlock, but I've seen a spike. All right, now I should go and figure out what has changed. So, or my backup times. How long are my backups taking? And I've seen my backup times increase. There was a big jump. Why was that? Is it something that's now a systemic problem, or was it a one-time blip? So those are a few of the places. Also, in the e-commerce side, you think about, I'm selling those beach umbrellas. They normally sell for $100, but I accidentally had a typo where I'm selling it for $1. Well, that does happen. Actually, more commonly with like the $2,000 television that accidentally sells for $20, which does happen on occasion. And being able to say, hey, your prices for the past month have all been, $1,800 to $2,200, and now you're putting us a price of $20. That's weird. Did you really mean that? So those are a few examples of places where you can look at historical trends with anomaly and point out anomalies and bring it to a user's attention.
Thanks. That's really interesting. I think particularly as you say, the fact that you've got the sort of the inward looking where you can use it for kind of diagnostics, and the outward looking where actually you're bringing it to business problems.
Yeah, because from the .NET code or the library we've built or whoever builds it, from that perspective, really all it is numeric data points over time. And it doesn't matter what the underlying value represents. That's where you as a human apply your knowledge and can give a better understanding of the nature of that anomaly and what goes on as a result.
Great, thank you.
So I've not seen any more questions coming through the chat panel. No.
I could keep following up, but I think it might be fair if I perhaps contact Kevin offline. So thanks very much, Kevin.
Yes, that was very interesting. So yeah, I did a lot of maths at sixth form in university, but yeah, it all gets a bit rusty around there. Statistics was never my favorite thing.
Yep, my joke on this is basically I'm giving you that course in college statistics that everybody tried to forget about.
Yeah.
Welcome back to the world of statistics.
Mechanics I'm fine with. Statistics, meh. I can do binary distribution, that's about it. Right, so I think next up we've got Mr. Taylor talking about Kubernetes. So if anyone wants to refresh their drinks, we should be going live with him in about 4 minutes. Oh, that's good. It looks like Philip finds that useful if he's for future work. Yeah, I think that's the sort of thing with these talks, that technology people don't necessarily think about when they're first doing it, but it is very handy, especially when you're taking large amounts of data. Yeah.
Yeah, I think that's interesting because a lot of the talks, understandably, are around bringing technologies to bear, or new technologies, but actually to bring some techniques, if you like, as well, is really fascinating to see that.
Thank you ever so much for that, Kevin. Yeah, that's it. Yeah.
And I apologize if anyone heard me calling Kevin a good boy during the talk. Unfortunately, my mic unmuted. I was calming an unruly puppy. Kevin is a very good boy.
Yeah.
But, Kevin is a very good boy.
Yes. Unfortunately, I don't think he was having his tummy tickled at the same time. So just in case that comes out in the recording, that's what it was.
That'll have to wait for when data relay resumes in person.
Yes. We hope it won't be too long.
Yes, let's hope so.
Right. So, Chris, are you about ready to go?
Yeah, can you guys hear and see me okay?
Yeah, I can hear and see you fine, yeah.
That's cool.
I'll let me share my screen as well.
Brilliant.
Yeah, that looks good.
Top banana.
All right. Thanks, everybody, and best of luck with the talk, Chris.
Thank you very much
Thanks,
again,
Kevin.
Kevin. Really
Thank
appreciate
you,
you turning
Kevin.
up.
Happy to be here.
It's all gone quiet. Everyone waiting for me.
Yeah,
to
doesn't
start.
it?
I think maybe we
Like,
should
And it's very
Sorry.
topical, your front introductory screen. I like that.
very
Yeah.
on brand. Good job.
I thought I'd
Yeah, on
I'll
brand.
put the effort
Yes.
in.
Also enjoying the word of Kubernetify as a verb. Is that your own linguistic invention, Chris, or is that something that's used more widely?
Sorry, I just took my earbud out and it disconnected for 2 seconds. Say it again. Sorry.
I was just enjoying the Kubernetify, this neologism as a verb. Is that something that you've thrown in here, or is that something that's being used more widely?
No, it's you've got to try and find a catchy title, and Kubernetify. So I'm taking your containers and putting them into Kubernetes, essentially Kubernetifying them. I might see if I can get it put in the Oxford Dictionary or something.
Yeah.
Don't think I'll get paid for it, like.
Right, I think we're at 8 o'clock.
Awesome. Well, we'll make a start. So welcome
So-
everyone to. Oops, sorry, Victoria. Were you
That sounds
gonna?
cool.
Am I good to go?
No, that's it. You carry on.
Yeah. Okay. Sorry. Right. It's these virtual conferences, not having somebody there telling me to stop. So welcome everyone to Data Relay, my session today, which is Kubernetify your containers, which you may have heard a little bit about us talking just 2 minutes ago. So we'll jump straight into it. We've only got 45 minutes, and this was originally, well, it was a 75-minute session, so I've cut this down quite significantly. So we'll try and get through as much as we can, as quick as we can. So a little bit about myself. My name's Chris Taylor. I'm a data platform architect for Data Masterminds. I am involved in the, used to be SQL Server community, we later called the data platform community. So I'm organizer of the Newcastle Data Platform and Cloud and the Power BI Newcastle. Used to play a lot of sport. I'm not as fit as I used to be, and certainly not as young as I used to be. So I now spend most of my time coaching, whether that's football or cricket. My contact details are on there. There will be a slide at the end. And these slides and the demos that we run through are already up on GitHub if you want to get them. So it's quite fitting that I'm doing the Northumbria session tonight, because I actually do live in Northumbria, a small town called Bedlington, which is that small that's not even listed on this map here. But you can see we are pretty much as close as you can get to Scotland without it actually being Scotland. And fun fact, there is actually signs for Edinburgh just on the outskirts of the town that I live in. Granted, they're 112 miles away, but it's still there. So what will we be looking at today? So we're going to talk very briefly about containers. It's a one slide thing. Moving into Kubernetes, a little bit about the architecture, kube control, focusing on Azure Kubernetes Service, AKS, and then again, just briefly touching on how we can use this with your Azure DevOps pipelines. What we won't be going into is a real deep dive into the architecture and internals. I've given some links to Anthony Nocentino's Pluralsight course and blog, where he does go into a real deep dive with some of this. So what are containers? So I'm hoping a lot of people have actually heard of containers. They may not have actually used them, but they're becoming more and more common. They've been around for a while now. So they were seen as the next evolution in virtualization. That's not to say they are virtual environment or to be compared with VMware or virtual machines, but they are a lightweight, standalone, executable package of a piece of software. So what exactly does that mean? So essentially everything that you need in order for your application to run is wrapped up in this image, which you can create a container from. So whether that's your code, any libraries, any tools, settings, configs, everything that you need is in there. So if I had something on my laptop and I wanted to give it to Victoria or Stuart, and they had the runtime environment on their machine, they should be able to run it and it should just work exactly the same. So I like this little snippet from the Microsoft Docs. Basically, a container is an isolated place where an application can run without affecting the rest of the system and without the system affecting the application. So you've got that level of isolation within it. So I do use containers quite a bit, but it's normally only 1 or 2 containers. I don't have a big swarm of them. So if you were in an environment where you had 100, 1,000, 10,000 containers, that can become quite difficult to manage. And that's where the likes of Kubernetes comes in. So this is essentially an orchestration engine. It's been around for a while now, and it is now, I suppose, the de facto standard. Everyone's sort of pushing towards Kubernetes as opposed to everything else that's on the market. So much so, Microsoft have invested heavily in this. So when you look at the big data clusters and Azure Arc, they're all running Kubernetes in the background. So you can see from what you've got there and how big they're going to be, that Kubernetes is something that you should really start having to take an interest in. So again, a little snippet from kubernetes.io. So Kubernetes is a portable, extensible, open source platform for managing containerized workloads and services that facilitates both declarative configuration and automation. So that means that we can script and code our deployments, and we can also have all this, the changes and everything that's part of the automation process and everything within it. The next couple of slides are more of a takeaway slide for you, but I'm just going to touch on them briefly in terms of some of the features that I like. So you've got load balancing built in. Not many tools have got that. Your automated rollouts and rollbacks, self-heal. So if a pod fails, it'll create a new one. Your application should still continue to run. Secrets and configuration management all built in, and horizontal scaling. Now that will, when we come into the demos, we'll see how that isn't really effective in the SQL Server world. What it isn't, it's not something that basically deploys your source code and builds your application for you. You've still got to do that. It's more of an environment that you can host your applications on. It doesn't dictate the type of logging or monitoring. You can't have anything that you want with that. And like I said, it does a lot for you, but there is still some work that you need to do yourself. So a lot of people may have heard of K8s and not really known, is there a difference between K8 and Kubernetes? Is it 2 different things? Essentially, it just is Kubernetes, but some smart arse decided to take the 8 letters between the K and the S and turned into K8s. And another fun fact for you, so if you don't learn anything from tonight's session, take this away if you can. Kubernetes means helmsman in Greek, person who drives or steers a ship. And you can see that with the Kubernetes logo, it's the wheel of a ship. So a little bit about the architecture of Kubernetes. So at the lowest level, you have your containers. And certainly with myself, I've been using Docker containers. That's primarily what I use. Now these containers live in something called a pod. Think of it as like a wrapper around them, where you can have that level of segregation between your containers, where you can specify the network and maybe security levels slightly different between your pods. And you can have one or many containers within a pod. As to whether you should have more than one is up for debate. Now, these pods live within nodes, and the nodes are either the physical or the virtual machines that you're going to be running. A group of these nodes is called a cluster, so your Kubernetes cluster. And with any Kubernetes cluster, whether it's a single node or multiple nodes, you will always have a master. So if you've only got a single node, that will also be the master node, where you have things like etcd, which is your key value store for all your configurations, the scheduler to make sure the pods are running on relevant nodes, all that's there. Now, certainly myself, and I imagine a lot of people on this session tonight are data people. And by their very definition, containers and Kubernetes they're there to be blown away. In the data world, if we lose our SQL Server, for example, and we lose our data, we probably lose our jobs and lives and wives and kids and all that. So storage and persistent storage is a very important aspect and part of this, certainly in tonight's session. So you will mount your volumes or your persistent volumes through claims. So you will have your disks essentially, and what your pods will do is take a claim of that and say, I want 5 gig of space, something like that. And these, you can either have these in either a read-write once, read-write many, where you can have it just connecting to one node and pod or multiple. And if you ultimately lose a node or a pod and it moves to a different node, your pods move somewhere else, that volume or that storage will move with it. When SQL Server 2019 came out, it was one of the big things that they were pushing for was, or advertising, was always on availability groups on Kubernetes. And that was a big thing. And there was like a big push, a lot of marketing. And then all of a sudden they turned around and said, actually, no, it's not going to be supported. And up until last month, there wasn't really much information out there or anyone really advertising it from a Microsoft perspective. But at the back end of March, you can see now that they are starting to pushing this again with the availability groups. So it does look like it's something that is coming. Now, that was a very whistle-stop tour of Kubernetes. We got through that relatively good in good time. So Victoria, anyone, is there any questions at this point before we jump into the demo? I'll take that as a no. Awesome. So no questions, we'll jump straight in. So I've got a notebook here with all the commands that we're going to be running through, and I'm not going to show you how we actually create a cluster, or I won't actually be creating it, because it is a very simple command. We're just going to run AKS create, give it a cluster name, the resource group, how many nodes you want in that cluster, and the size of the VMs within it. Very simple. Main reason for not having it in this demo is because it's in the cloud and I can't predict how long that's going to take. It could take 5 minutes, it could take 25 minutes. So I've already pre-built that. So in the slides, I very briefly touched on kube control or kubectl, or as Buck Woody would say, kubectl. Yeah, you take your pick as to how you want to pronounce that. And pretty much anything that you do within Kubernetes is going to start with kube control. It's the same like with Docker. It was always Docker run or Docker pull, Docker this, Docker that. It's the same with Kubernetes. So because you can have multiple clusters, you've got various different contexts, or Kubernetes is seen as context. So if I run kube control config get context, you will see here that I've got, I zoom in, 1, 2, 3, 4, 5 clusters that I can access at the moment. Now, as you will see, there is these two here, or I'll class them as on-prem. They're on my laptop. One's just through Docker Desktop, and another one, free version that you can use, download and put on your machine, start having a play around for free, is Minikube. But in this session tonight, we're going to be looking at Azure Kubernetes Service, and that cluster is called AKS Cluster Demo. So as you can see, so I forgot to mention here, you'll see this little star, which indicates which context I'm running as or running under. If I wasn't running under AKS cluster demo, I could run simple command of kube control, config use context, and give it the cluster name that I'm going to be using. So we can just F5 that, and we'll see that it's already switched. I was already in it anyway. Then you can start looking at information regarding the cluster itself. You've got the kube control cluster info. You can get some extensive information by passing in the word dump. I'm not going to do that because the amount of information is horrific, and it takes about 30 seconds for it to actually stop. So we're not going to bother with that, but it gives you a lot of information just off the bat as to what the control plane is and where things are running. And you can see I've got this in UK South. So if you do have any issues with your cluster, this may be a good place to start. So we also have the concept of a namespace, which is a logical way of separating your environment. So we could have a cluster, and we could make that, we could have, like, say, a dev, a test, and staging environments running off that cluster. Obviously, you've got to think of the hardware underlying and whether it can support it. But if you want to segregate those environments, you can do that through a namespace. So at the moment, we have the default ones that's created as part of your Kubernetes cluster. And you can see I've had this cluster up for 31 days. And I've got this simple upgrade, which we'll come on to a little bit later. But for the demos leading up to that, I'm going to create a new namespace called demo, and everything that I'm going to create up to the end of the demo, between now and the end, will be done in this demo namespace. And that's it, as easy as that. We can see that the namespace demo has been created. We can also have a look at the nodes. Now, because I am from the Northeast and I'm tight, I'm not quite Yorkshire level tight, but I do like to conserve money where I can. I've made this just a single node cluster. And as you can see, we've got the node pool. And if we had more than one node, you would see those listed in there. So as with any data person, persistent data and making sure it's there and available is a very, very important thing, as part of your life, not just your job, but life in general. So with SQL Server, it's a relational database management system, and you want to persist your data. You don't want to lose that data. So what we're going to look at now is how we can do that and how easy it is. So the files that you can use within Kubernetes are YAML files. I assume a lot of people have heard of them. They are great, fantastic, fantastic thing to be using within Kubernetes, but it does have its caveats in terms of, if you speak to anyone who's used them, just mention tabs and spaces and they will know what you're talking about. Because if you get your tabs and spaces wrong, your file doesn't work. So all we're going to do here is, the first thing we're going to look at as part of persistent data is a storage class. So I've got a YAML file where I'm going to tell Kubernetes what type of storage I want. And in here, you will see in this particular file, it's of kind storage class, just giving it a metadata name. And then I can give it what sort of disk I want. In AKS, you can use Azure Disk. I've also got an example down here as well, where you can use the Azure file. And you can use standard or premium, locally redundant, geo-redundant, whichever you fancy. Obviously, the bigger and fancier the disks are, the more expensive it's going to be. So just bear that in mind. So in order to actually deploy this, we've got a command, believe it or not, kube control, but we're going to apply that file, and obviously with a -f to say it's a file, and the file itself, which is storage class. So if I run that, we should see that the storage class, so that basically that information in that file has been deployed. And we can start checking things regarding the storage class and everything else. So with the kube control get, and you will see here I've got two commands in here, kube control get storage class and get sc. So there is some shortcuts in terms of the code that you can use. And essentially it will give me the same information here, telling us the provisioner, the reclaim policy, whether it's bound or not. And this is essentially the one that we've just created here, the SC AKS demo. Now, in order for SQL Server to, or any pod, I suppose, to get access to this storage, it's all through a persistent volume claim. So we're going to, as mentioned in the slides, we're going to make claim to that storage. And in the demo that we've got tonight, I'm going to create 3 volumes. One PVC, persistent volume claim, AKS MSQL, one for the system databases, one for my data files, and if it's, yeah, it's on here, and the log files as well. Because I'm a good DBA and I'm splitting my, well, old school DBA, and I'm splitting my data from my logs. And in here, you've got the access modes. So also in the slides, we mentioned about those that can connect to one pod, or those that can connect to many. And these are just going to be read-write ones, so I can only make them access a single pod. And the storage itself is going to be 5 gig. And we can apply that in the same way as we did before with kube control apply. And you'll see here that these 3 persistent volume claims have been created. As quick as that. Now again, using kube control get and also PVC, which is a shortcut for persistent volume claim. Let me just run that again because it was a little bit too quick. We will see that the same information, regardless of how you run it, is output. And because of the way that this file has been generated or was created, when I did the persistent volume claim, it has also dynamically generated the volume as well. So you can do it that way, or you do, if you do have some Kubernetes administrators, they could create the volumes and you just make the claims from that. So we can see here with the kube control get persistent volume that we actually have the volumes dynamically created based off what we were wanting from that claim. So pretty cool stuff with that. And we can see what the claim is that's requested it. So in the slides, we also mentioned secrets and the secret management within, well, not a secret management as it's a secret, but the management of secrets within Kubernetes. And that is something that we're going to use for the SA password, because I don't want to store password 1 in my YAML files. So I'm going to create a secret within my cluster, which will be stored and I can reference it later down the line. So again, very simple, kube control create this time. I'm telling it what I want to create, which is a secret or generic. Give it its name, secret AKS MSQL. And for anything, I'm going to refer to it as the SA password. So when I want the SA password, it will look at this particular secret. We can have a quick check of that with kube control get. And we can see that that's been created down here. Now, a command that we haven't seen up until this point is kube control describe. Now, a bit like the get, this will give us some information about whatever it is we're requesting, but a lot more detail. So in terms of, well, the secrets maybe not so much of a lot more detail, but we can get the information such as SA password. But when we look to use describe, when we're looking at some of the pods, you'll see how useful it can become, certainly when it comes to troubleshooting. Touch wood, we won't have to do too much troubleshooting, but let's see how we get on. So now we've got our persistent volumes created. We've staked a claim to it. Now we want to deploy SQL Server using those. So again, using the kube control apply, passing in the YAML file, which we will have a look at in a moment, this is going to deploy SQL Server, a container, essentially within a pod. And we do that, see how if I can get everything on here, we may or may not. With the YAML file, as we saw before with the storage class, we give it a particular type of file that we are. So we're looking at a deployment this time. Going to give it the name, AKS SQL Server, give it some labels. If I scroll down, we will start seeing how we can configure and give a specification spec of this particular container and how it will run on Kubernetes. So first thing you'll see here, which is one of the most important ones, is the actual image that is going to be running, the base OS, essentially of your container itself. I have created my own version of Cumulative Update 21 for SQL 2017 here, and added that to my own Microsoft Container Registry, which is at this location here. You can go straight to the Microsoft ones if you so desire, or you can create your own. What I will say is if you create your own, you've got to think of the access policies between your cluster and the container registry as well. Resources and limits. So these are very, very important if you're planning on running multiple namespaces or multiple pods on a node. Certainly in my case, I've only got a single node. So I've got to be careful in terms of not to oversubscribe, over provision what I've got. So you can give it sort of a minimum and a maximum. So when this pod's created, I'm going to say I want to give it 2 gig of RAM and 2 CPUs, but I don't want it to take any more than 8 and 4 CPUs. Now the machine that the node, or the virtual machine, the node itself, which this is running on, it's got 4 CPUs and it's 16 gig of RAM. So running this in itself should be fine. If I go to start trying to deploy some more, I might struggle. And similar, if you've done anything with Docker, you're going to give it the port, which is going to say 1433. I'm going to use the developer edition, accept the EULA, and I may have to come out of that and scroll down a little bit more. And the secret that we created before for the SA password, we're actually going to pull that in. And when this is created, it's going to create an SA password using that password one that I set earlier on. Now, the persistent volumes that we created, I'm now going to mount those as part of this deployment to the internal file structure of this container. And what that essentially means is that, as we'll see in the demos in a moment, if this pod dies or we delete the deployment, anything that we've created should just reattach if we're using the same deployment, which tells it to map to the same file structure. And that includes a master database. So we've got our volume mount. So we're saying now I want to mount the system databases to var opt MS SQL, which is like the default within the SQL on Linux, and create a new folder for demo data and demo log. And that's where my data and log files are going to be created. And something that I also do have in the file is something called a service, which we'll come on to in a moment, but I'll briefly touch on it now. So if you want to access this cluster externally, you're going to have to expose it. You're going to have to give it a public IP address for you to be able to get access to that. And that's what we're doing with this load balancer service. So we have got our deployment there, AKS SQL Server. We can see we've got one node of 1. I have put a comment in here saying it can take up to 70 seconds. And the majority of that time is the attaching of the volumes to the pod itself. Spinning up SQL Server without any persistent storage is relatively quick. So we're going to have a look at kubectl get pod. So we're actually going to see what it's running here. This little command that I'm setting the variable pod name is essentially the same command as above, but I'm outputting it as JSON and trying to get the metadata name so I can use that pod name in commands a little bit further down. So we can jump in and have a look at the logs. So what exactly is it done? So those of you that know SQL Server will see that this is pretty much or very similar to what you would see when you're starting up SQL. The kubectl describe, as I mentioned before, so if anything goes wrong with your pod, this is a very good command to run, because down at the bottom, it will show you a list of events as to what's actually been happening. So you will see here that it's tried to attach the volumes and it succeeded. It failed at that point, it must have timed out, but then it's actually managed to attach it on the second attempt. And the fact that it's trying to download, well, in this case, the image is already present. If it wasn't, it would be saying it's trying to download it, how long it takes. And the fact it's created it and started it. Now, in the YAML file for the deployment, I created a service. We're actually going to show you a command to do it a different way as well. So we're going to use the kubectl expose. I'm going to create another external IP address. And if I have a look at both of those, a little bit quick with that, I think. We will see here that I could actually use either of these IP addresses to connect to my SQL Server now. So now that we've got that up and running, I was going to set a variable to get the IP, and I'm going to use DBA tools, just first of all to check what version of SQL Server can I actually connect. Just a very simple command. Yes, I can. It's on cumulative update 21. Then I'm going to run create database, create login, and just do some configuration of the SQL Server itself. So we can just double check that they have created. Certainly have. So we've got demo1 database and a test1 login. So they now exist on that persistent storage. So if we go in and start trying to break this, so if we go in and try and delete a pod using kubectl delete, and I'm going to pass in the pod name, and this may or may not show what's happening when that, no, it doesn't. But sometimes if I catch that right, it will show you that it's terminating one pod and then it's starting up the next one. And you'll see here, it's obviously already terminated it, and it's doing creating the new one on the relevant node. So we may be able to see some of the logs here, and we can see that SQL Server is running again. If I try and connect to that same instance, we will see that it's back up and running. So that was relatively quick. That pod died, it spun straight back up. Now we can take it a step further, and we saw that we created all this through deployment. I'm actually going to go in and delete that deployment. We should hopefully see that it is terminating. If I run that again, that pod should be still there, should be gone. Typical, still try to delete it. There we go. So that's now gone. So that SQL Server is no more. I can't connect to it. But I could go in and just reapply that deployment. Or I could give it a different file if I wanted, a different spec or anything like that. And then hopefully that will go back in and that will create this new deployment. And if I look at kubectl get, it's going to be starting it up. Now, as I mentioned before, the persistent volume claim is the bulk of this time. And certainly with this demo, because I've deleted it and trying to recreate it, it seems to take a little bit longer than it should. So that could take up to a couple of minutes. So we'll just have a quick look at some of the next steps, maybe come back to that. So you can see the pod is still running. If we describe that pod, we will see here, it's moving quicker than I thought at the moment. It's trying to attach, or it's attached one volume. It's still got the other two to do. See if it's actually being a bit quicker if I try and run that again. And there we go. So actually those are attached. So this could be up a lot quicker than I thought. Maybe it's not. But essentially, yes, we'll come back to that in a moment. But what that's doing is it's just reattaching that storage, the database, the master database. It's all just going to be magically back where it is. Now, we mentioned scaling before. So we've only, in our deployment, we've only set it as one replica. So essentially one pod for SQL Server. We could scale that very easily using kube control scale, give it the deployment, which is AKS SQL Server, and how many replicas we want. Now I'm going to up that to 3. And we have a look, and we're going to have 3 pods. One of them is running. So that is now up and running, the one that we redeployed before. And the other 2 are sat in a pending state. Now, the problem that we have, if we go back to what I was saying before, let's not run that, is around provisioning and limitations of your actual hardware that you're running this on, the actual virtual machine. So if I take one of the nodes that's in the pending state, you'll see here, as this is saying, there's insufficient CPU. So it's ultimately not going to load because I don't have enough CPUs on that virtual machine that I've used. So something to bear in mind with that. Other errors that you may see as well is if you've got your CPU limits and everything right, you may see an issue about 2 pods trying to use the same master.mdf file. The same rules as standard SQL Server apply. Once something's got a hold of that master database or your demo database files, nothing else can. So you've got to try and think a little bit about that. The scaling out isn't quite like scaling out an application. So I'm just going to push that back. And I'm going to scale that back down to just 1 replica. And we'll see that that one that was up and running is still there. So anyone who does work with SQL Server will know how much of a pain it actually is to patch it. It's not as bad these days, but it used to be horrific. In Kubernetes, you can upgrade or patch, your SQL Server relatively easily. So we've got a kube control rollout history where we're just going to pass in the deployment name. And we can see here that I've only got 1 revision for that because that's the deployment I've made. The eagle-eyed among us will see that actually this deployment has got a different name and a different namespace. This is the simple upgrade namespace. So the reason I've done this is because I couldn't get consistent timings for this demo. And obviously to fit it in 45 minutes, it was going to be tough because it was anywhere between 1 minute, 10 minutes was the maximum, but usually between 1 and 5. And again, that all came down to the persistent storage and reapplying it. So I've just created a very basic SQL Server deployment with no persistent volume claims. If we have a look at that, we can see that we're on RTM CU21, and we're going to upgrade that. And there's a couple of ways we can do that. We can do another deployment, use the kube control apply. And I've got a different YAML file here. I'm going to call it 2017 upgrade. And if I run that, and then we have a look at what that file contains, as you can see, this is a lot smaller than the previous one, but essentially the file itself, all I've done is I've just changed the image name. So I've given it cumulative update 23 as opposed to 21. And you can see I've given it some crazy low requests and limits there. So if I run kube control get pods, we can see that that's actually already up and running. If I get a pod name and the describe for it, we will see that the container image is already present on the machine. And if I try and query that, we should see that we are now in cumulative update 23. So that upgraded relatively simply, very quickly as well. But what I will say is if you've got persistent volumes and you've got databases on there, it will go through the upgrade process for those databases as well. So just bear that in mind, just like any upgrade to SQL Server or any patch with SQL Server, it may want to upgrade the databases. So it can take a little bit of time. The other way that we can do this, and we'll do this to reverse it back down to Kube Update 21, if we found that our deployment just doesn't work, our databases don't like it, we can run a command, kube control set image, again, giving it the deployment, and then telling that deployment which image we want to use. And I'm just going to say I want to go back to Kube Update 21. Simple as that. We will see running the kube control rollout history that we've got a revision 2 and a revision 3 now to show that we've actually been making changes. And if I try and get the logs of that, and I've timed it right, we will see that we have SQL Server 2017, cumulative update 21, and everything else that's in there. If you decide you want to get rid of everything, this is actually quite a dangerous command, so be careful not to run this in any sort of production environment, but kube control delete, and I can run this, and this will basically make it as though my demos did not even exist. So we'll leave that for now. One thing, just before we jump back into the slides for the last 5 minutes or so, something I want to mention is, like with anything in the cloud, this is constantly changing. So every time I do this session, something has changed. So there used to be, or there still is, a Kubernetes dashboard in versions of the cluster of Kubernetes before 1.18. It used to be enabled by default. In version 1.18, it's disabled by default. Version 1.19, it's not available at all. So it's all now just accessible through the Azure portal. Just before I do jump back to the slides, I mentioned a bit about the Azure Devops side of things. So this is a screen from one of my other sessions with Azure Devops using Kubernetes, where we can spin up a cluster. And I mentioned about namespaces. So in here, we've got a test and a staging. This is actually a separate cluster, and your dev database, which is just run in a single standalone container, not in Kubernetes. So you can start making changes to your database, have an environment, your SQL Server running on Kubernetes. You could even have it spin up. You do your deployment, run your tests, and then spin it back down again if you so desire. So it's all there, easy to use, easy to configure. Everything links in very, very well. So into the last 4 minutes or so. So this is a slide on the Azure DevOps that we were just talking about there, where we've got a dev environment, we've made our changes, we push that code into the Azure repo. In that particular demo, what it does is it will build a Docker image with those changes embedded in it. So think of it for a dev environment where you've got an empty database, essentially, or with minimal data. You can deploy your changes, run some tests, push that to container registry, and devs can pull that down and have an image with all those changes on it. But we can also push those changes directly to a database sat on Kubernetes. Where do you test? Do you test once it gets to Kubernetes? Do you test when you're building the Docker image? Do you test when you check your code in? Check everywhere you can, or test everywhere you can. The more testing you do, the better your product's going to be. For those who are moving from Docker to Kubernetes, there is a great tool called Compose, spelled with a K, where you can pass in your Docker files and it will automatically change them into the relevant deployment files for you just by running Compose, pass in your Docker Compose file, convert, and it will create all your YAML files nice and easy for you. Bit of a summary. So some of the pros, this runs on many platforms. I've used Linux tonight. You could use Windows. Obviously, the images and containers for Windows are a lot larger. You've got your scaling, your self-healing. Obviously, remember the caveats about scaling with SQL Server. You can manage your infrastructure as code. Everything was done through those YAML files, built-in load balancers. You saw how quickly it was to deploy. Obviously, the persistent volume claims take a little while longer, but to have SQL Server with persistent storage up and running within a couple of minutes is not a massive thing. It is when you've got 45 minutes in a session, but in the real world, it's not a huge thing. Some of the cons, this is very different for a lot of people in the concept of how these sort of environments work. So it can take a little while for people to get their head around it. Things like the resource limits, we saw in the demo that if you have your resource limits wrong, you're not going to be able to deploy your pods or deploy your containers in your pods. And always read the changelog before you actually update your cluster, because it's always changing and there's always something that breaks. Very high level summary of what we've been through. There's my contact details, and we'll leave it there. Hopefully not far off being bang on time, Victoria, I don't know.
No, that's really good. I've got a couple of questions for you in the chat window.
Right.
One that says, can you give some real world examples where you found Kubernetes a better solution for a SQL setup than more traditional installs, please?
So I'm assuming they mean by more traditional installs as in just installing SQL Server on a virtual machine or on a physical machine or multi-instance. So you've got to think, let's go back to a Docker image, and the fact that SQL on Linux itself is about, well, last time I checked, it was about 1.5 gig in size. And for you to get your environments up and running quickly and use significantly less space in terms of the install, you're never going to beat the container side of things. If you're installing SQL Server on a virtual machine or a physical machine, even multi-instance, you've got to think of the size of what that installation is and how long it takes. Even if you've got your provisioning of the virtual machine and the installation of SQL all automated, you're probably looking 20 to 30 minutes. That's absolute best, where it's just a one-click deployment. With your containers and with your Kubernetes and containers on them, you saw with a one-line script, we had SQL Server up and running within a few seconds, depending how you configure it. Don't know if that answers the question. Obviously, feel free to come back and say I haven't.
If that doesn't answer your question, could you put something further in the chat window, please, Pete? That'd be brilliant. I've got another question as well, Chris. Mm-hmm. Would you use Kubernetes in production environment?
I'll answer that with saying, from a technical perspective, there's no reason not to. This is all fully supported by Microsoft. What you've got to think is that I don't personally know anyone who is running it in production. I know several people and customers of ours who are running it in dev and test environments. But that's not to say that there isn't people running this in production. I just don't personally know of anyone. So I think until I do know somebody and I know the potential horror stories that they've been through, I would err on the side of caution with it. Certainly, if you're going to look to do it, try and speak to the relevant people at Microsoft and see if you can get some support and backing from them. Because I'm sure if you go to them and say, we've got a huge production environment and we want to go to Kubernetes, they'll chomp at the bit to come and try and help you. Again, I'm skirting around a lot of the answers here, aren't I?
Yeah, no, both people are happy with the answers, and that's brilliant. So
Awesome.
If there's any more questions, please just add them to the chat.
Yeah, I was going to say, obviously, my details are on here. By all means, drop me an email, DM me on Twitter, or come to you guys to get in touch with me. You see, the slides and demos are up on GitHub if you want to have a look. And hopefully everything should just work out the box once you've got your cluster up and running. But if not, and you're having problems or difficulties with it, my details are there. I'll answer questions all day long.
Chris, I wondered
That's
if I could ask a
brilliant.
question while I've got you. Thanks very much for a great session.
Sure.
The question was, you mentioned briefly testing in the DevOps pipeline slide. And I wondered, and you also said, where to test and sort of suggested perhaps sort of test everywhere you can. Are you anticipating sort of in that model where you sort of test as much as you can, as often as you can, are you anticipating different sorts of tests at different stages there? So maybe unit testing at one stage, functional testing at another, something like that? Or just retesting everything because the environments are all subtly different?
No. It would be different. Let me go back to the slide. It was a slide, wasn't it? So if I go back to this one, we have a look here. So you would potentially run different types of tests. Now, every development environment is going to be different. Well, potentially different. Everyone works in a different way. But, you can have your tests on check-in. You could have, just very basic tests is, I don't know, syntax, code smells, things like that. This particular example, what I was trying to show in this demo, in this session, the Azure DevOps one, is can you deploy your changes to an Azure a Docker container, and have it within that, so somebody can just do a Docker pull and pull that down and have those changes within it. Now you can, in that session, I show how you can apply T-SQL-T tests at that point as well, and obviously some of the pros and cons around doing that, so that your image will either will either create or it won't. If a test fails, then you don't want that image because it's broken. You may want it to pass, or not pass, you may want it to create so that somebody can pull that down and troubleshoot it. But that's very much for dev environments, because you've got to think with your Docker image itself, if you've got a database that's a terabyte in size and you try and put that in your Docker image, that image itself, that image file is going to be a terabyte in size. So that's very much for cut down versions of your database, schema only, or just with enough data so the application will run, so the developers can do what they need to do. Once you get to sort of this point in the slide here, you can then, through your Azure DevOps pipeline, you could push your changes from your database project straight into, for example, Kubernetes. It could be that you go to Azure SQL database or SQL on a Azure VM, wherever your SQL Server databases are. Kubernetes is just an example, and this is showcasing how to do that. You can have, I'll see if I can show you some of the tests that I may have in that environment as well. So in this particular demo, oh, this is not working. Go back in, see if this will let me edit. Didn't mean to edit the release, it was the pipeline I wanted. So in the test, when I'm deploying it to a test environment, I've got some T-SQL-T tests, and I also have some pester tests as well. So you can, within your pipeline itself, you can, also in your task list, you can have any sort of test you want, within reason, obviously. But with pester being as powerful as it is, there's very little that you wouldn't be able to do against the database. So I suppose that was a very long-winded way of answering your question, to say that I would do different types of testing at different stages, apart from perhaps if you were building a Docker image, you may want very similar tests at that point to what you do once it's actually being deployed.
Great, thanks very much. I'd say thorough, not long-winded. Thanks very much. That's really helpful.
No problem. Any more, Victoria?
No more questions.
Wow, it is.
So I think any news to say. Thank you very much, Chris, for your excellent session.
No
And
problem.
I hope everyone's enjoyed that. I've put in the chat the feedback form. If you could please fill that in, that would be really, really helpful for the event. We'll share that again on social medias as well. Oh, I see another comment coming in. Oh, that was a thank you to the talk from Philip to you.
Awesome.
That's
Thanks
all.
for attending, Philip.
Yep. So, and if you're free tomorrow, feel free to sign up for the next leg of our exciting data relay. We're in East Anglia tomorrow with a couple of great sessions, one on mental health and well-being, and the Edge of Tomorrow, Introduction to Graph Databases, well worth attending as well. So, and I'd say thank you very much to for attending today.
I say the good news
And
is, Victoria, you don't need to pack everything up and move to the next venue now.
No, that's it. Yeah, that is the advantage of virtual, isn't it?
Yeah. I'm not missing 3 hours on a coach either.
Maybe it's next year, Stuart. Next year.
Yeah, we'll be back. I think, we've said as soon as it's safe, we'll be back. We did talk about doing October. We just don't think enough people will be confident, vaccinated, or venues will be that secure. Unfortunately, data relay is pretty much a definition of a super spreader event.
Yeah.
So we will be back. We're just waiting for dates.
Option. Leave it till it's safe.
Yeah, it's much more fun in person.
The beers.
Oh yes.
Yeah.
Neither confirm nor deny. That's one of the reasons we do it.
I thought it was the only reason.
Yeah. Aye.
Or it's the tech as well. There's more thanks flooding into the chat there as well, Chris, for your session. That was really good. Thank you.
Awesome. Thank you very much, everyone.
Yeah.
Right,
Don't know, you see, I can't see the Q&A or the chat or anything. I don't think. Oh
no,
I
can
can.
You not?
I can. Yes, I'm telling lies.
All right.
He's just hidden a bit.
Problem in chair, not in computer. Even though I'm stood up.
Right. Well, I found that when I shared my screen in Zoom, I couldn't actually see chat at all. So, but
first world problems, isn't it? It
is. Yeah, different technologies, all the same. End up using Teams most of the time. So.
It's like I was complaining. I don't know if you can see the mouse that I've got. It's like one of the rollerball type ones. I don't know if it's well. And then I had to do, it's like proper roll school. I had to pop the rollerball out and clean the inside of the mouse. Like what we used to do off of the 90s, haven't had to do that in almost 20 years.
No, that's one thing I love. I'm Apple Magic Trackpad. It's just like doesn't need cleaning. Asian Mr. Sheen.
Fancy pants, that's what it is.
That's it. Well, work paid for it, so I'm quite happy to use it.
There you go then. Definitely do that.
Okay. Well, I think thank you very much for everyone who attended tonight. I think we're about on time, aren't we? Excellent.
We are, yes.
Yeah, again, thanks to Ian. Yeah, as soon as it's safe, we'll be out there, so we'll look forward to you coming back. We won't push it any earlier than we can do.
No, just looking forward to back on a full event thing in live person, won't it? Because that would be brilliant. So, but don't forget tomorrow, more wonderful sessions. So.
Who's on tomorrow? Sorry to put you on the spot there. What's the?
It's all right, Tracy.
Tracy.
Boggiano, is it?
Yeah,
Yes.
Yeah, that's her name. Yeah, and Mark Broadbent.
Awesome.
Yeah.
Guaranteed to be good sessions as well.
That's it. Yeah, we purposely went back and picked people like yourself who've spoken at Relay before and got good feedback.
Friday, we've got Annette Allen.
She's doing a double act with Jonathan, isn't she?
Yes. Actually, that should be interesting. I've not seen them ever present together before.
I don't think they have. Imagine if it
yeah,
turns into a
that'll
big
be
fight,
interesting.
you know. And...
No.
Yes. My money's on Annette.
Definitely, 100%.
Yeah. See if Rob can get there fast enough to referee. Hi.
Yeah, man.
Excellent.
Awesome. Right, I'm going
Right.
to shoot, guys, but thank you very much. I really do
Thanks
appreciate
for coming along. Yes.
being here. And anyone else who is still on here, if there is any more questions, my details are there.
Yeah.
Or just look for SQL Geordie on Twitter and spam me that way. It's perfectly fine.
Yeah, right. Thank you. And we shall end the meeting, which I think is in my domain.
Yep, you're the host in a minute, Vic.
Yeah, so I press the end button and we shall end.
Bye.
Night, everyone.
Bye.